Day is questions first, and then we'll go over just a few kind of quick problems, and then we'll go from there. What do you got?
Give you number 14.
Sure. Nobody asked. I was gonna bring that one up anyway, so perfect. Number 14 on that worksheet. So part of the reason I handed out those practice problems for today is because one of the main points I want to make today is sometimes when you're doing sums, series type problems, it's easier to use a formula, and other times it's easier to use the just do it by hand, basically. Okay, so I want you to make sure you're thinking about that. Quick heads up on this one. Take a look at 13 first. If you notice on number 13, they're asking you to find the sum of the 5th through the 11th term. In that case, would you use a formula or would you just find them and add them up? Okay, yeah, I mean, you could use a formula, but it's pretty quick to just find those terms and add those 6 terms up. Okay, so just a heads up on that one. When you get to number 14, on the other hand, when you're going from the 3rd to the 37th term, you're not going to want to have to find every single one of those terms and then add them up. So we're going to want to use a formula. So let me put this down here quick. All right, and for 13 through 18, just as a heads up, when the directions when they say evaluate the arithmetic series, what does it mean to evaluate a series? Yeah, get the sum. Okay, a series is a sum. So you're trying to get the sum of this arithmetic series, which means, if you look at your green formula sheet, you've got this formula. And so if we take a look as we work our way through this formula, there's 2 things that you have to be aware of on this problem when we're not starting with the first term. Okay, there's a couple things that we have to consider. So remember, n in that formula is the number of terms that you're going to add up. So if you think about that for a second, if we're starting with the 3rd term and going to the 37th, first question I have, because we're going to get to how many terms in a second. How many common differences would you add to get from the 3rd to the 37th? You'd have 34 common differences, which means how many total terms are there then? 35 total terms. You'd have 34 common differences to get from there to there, which means there's actually a total, when you include the 3rd term, of 35 terms. Okay? So what you're actually doing is you're finding the sum of 35 terms. Okay? So that means n is 35. And then here's the other, so that's the first part. Here's the other part. When this a sub 1 is representing the first term that you're taking the sum of, it doesn't necessarily have to be the first term in the sequence. It's the first term that you're going to take the sum of, which in this case is actually the 3rd term. So we plug in 3. So that's not really a sub 1 in this problem. It's actually a sub 3. Okay? It's the first term you're going to start with, is the idea. So if I plug 3 in, we end up with negative 14. That's the value of the first term that I'm going to take the sum of. And now the rest of the formula should be fairly straightforward. A sub n is always the last term, which in this case is the 37th. So you plug 37 in to find the value of the last term. Should be negative 100 something. So we have it, 16? Okay. Negative 116 is the value of the 37th term. And then now we just get an answer at this point. Okay? Once you've got all the parts, then you can just plug it in and get an answer. Okay? Sum of the first 35, or sum of the 35 terms. First one is value is negative 14. Last value is negative 116. And now that should give you the answer then that's on the answer key. Okay? Other questions? Anything else you want to go over? Anything else that you want to go over from the assignment? Any other? Again, now's the time to ask if you have them. So.
You should do 17.
Okay, let's take a look at 17. Quick question, by the way, on number 17. Why is the next term negative 7? Because it's actually negative 21 thirds. They just reduced it. So if we keep that pattern going, okay, and it says we're going to n equals 20. First question, what is the pattern? What's the common difference here? Yeah, you're adding a third every time. From negative 23 thirds to negative 22 thirds to negative 20, you're adding 1/3, okay, every single time. So in this case, I'm just going to write it down for later. My common difference here is a positive 1/3. Okay? So again, this is in that same section of find the sum, evaluate the sum. So same formula that we were just talking about. And if we put that down, again, in this case, how many terms am I finding the sum of? This one's more straightforward. We're finding the sum of the first 20. Okay? So we've got S sub 20 equal to, that means 20 terms. What's A sub 1? It is the first term. You have that. Negative 23 thirds. Plus A sub n then is the value of the last term of this series, which means I need A sub 20. It's the one thing in this problem you got to find. How do I find A sub 20? You go back to your arithmetic sequence formula, the one at the top of the page, the one on the top of your formula sheet, this one. This is your two things about this formula, just quickly, again, to clear some things up in terms of terminology. When they ask you in any of these questions to find the explicit formula, this is the explicit formula for an arithmetic sequence. You plug in your first term and common difference and then simplify, and that gives you the formula. Okay. So in this case, this is also your sequence formula, whereas we can go through and use this to find the value of any number in the sequence. That's what this is for. Okay? So if I'm trying to find the 20th term, I need to plug in the first term. I can plug in 20. I can plug in the common difference, and I can get an answer. Okay? So let's do that. Let's start with that. A sub 20 equals, first term is negative 23 thirds. If I plug in n equals 20, that means we're doing 19 common differences. And we said, I told you at the beginning, common difference was 1/3. Okay. This one you can actually, even though it's messy, you can actually do this one in your head. You got 19 thirds here. Negative 23 thirds plus 19 thirds gives you the 20th term is a negative 4 thirds. And now you've got the information you need. That negative 4 thirds is the last term in this sequence. You can now plug that in, and now you can get an answer for the sum of the first 20. Okay. Questions on that? Not sure where anything's coming from here? Again, you had to recognize that it's a sum first, using the formula, and the one thing that was missing was the value of the last term. That's why we had to do that other part. I needed to find the value of the last term so that I could plug it in. Okay? It's kind of like when we do stuff like that. For those of you that are in physics, that's what it kind of feels like to me. That you're using one formula to find something, then you plug it into a next formula to find something else, and then you go to another formula. It's kind of what happens in physics a lot of times. Other questions? Anything else before we move forward? Or is that making some sense? Okay, so then in that case, go to the note sheet that I gave you. And like I said, this is not going to take us very long because I'm not necessarily going to evaluate all of these. The main thing I wanted to take a look at, we're only going to do one of them, is this a formula problem or would this be a do it by hand problem? Okay? Because as always, when you get to a test, You're always a little bit kind of crammed for time. So you want to be able to think it through. Which way is the most efficient way to get to the answer? Versus, I can get the answer, but it's going to take me 15 minutes to do one problem. Okay? When there's a different way that could get you there in 2 minutes. So you want to always kind of consider that. If this was your problem, okay, you're finding the sum of the 0 through the 8th term, would you use a formula on this one, or would you just do this one by hand? I'd say either way on this one, it's really not that big of a deal. This one's probably not, it doesn't really matter. You could plug in 0, get an answer, plug in 1, plug in 2. Might get a little bit long because you do have 9 terms you got to find and then add them all up. But this one I would say, like I said, I'm not even going to do the problem. This one I would go through and say, either way, it doesn't really matter. Okay? How about if you take a look, how about this one? First 2 trips around the field, farmer bales 93 and 89 bales of hay. If the pattern continues, estimate the total number of bales if he made 6 more trips. Formula or by hand? Say this one is definitely probably a by hand one. You're starting off with 93 first time around, then 89. What would be the next term? Yeah, you're subtracting. There's 4 less every time. So if the pattern continues, you'd be at 85, then you'd have 81, and very quickly you can find those and add them up. So this one, again, I'm not even going to worry about the answer. This one would be a by hand type of problem. Okay? How about this one? Assuming, and if you notice, I covered up the picture. Assuming you didn't have the picture. For this one, would you go through and would you do formula or would you do by hand? This one I would go with the formula, because if we're finding the sum of all the logs, our formula that we have, this one that we've been using, we've already got the first term. Okay? The top row, well, you've got 15 logs. You've already got the bottom row, the last term, you got 24. The only thing you really have to figure out is how many rows are there. And in this case, that's kind of where, that's the nice part about giving you the picture. You could just very quickly check and find out that there's 10 rows. Okay? Or, again, you'd kind of have to work your way through and figure out how many rows do I actually have. So in this one, I think I'd actually use a formula. Okay? If you did not have that picture, well, even if you had the picture, you don't want to sit there and count every single log in the picture. You can, but it'd be a lot quicker. All right, last one. This one is the one I do actually want to do. This won't take very long, but this is the one I want to do. If we're going to find the sum of the first 100 even natural numbers. First question, let's do a quick refresher. What's a natural number? Anybody remember? It's been a long time. I think we did that in like one of the first sections of the whole year. Yeah, positive whole numbers. Your natural numbers are your counting numbers. So like 1, 2, 3, 4, 5, 6. They're the positive whole numbers. Which means if we're trying to find the sum of the first 100 positive even whole numbers, formula or do it by hand? I was going to say, I hope this one's pretty obvious that we're not going to 2, then 4, then 6, then 8, write them all out, add them all up. It'll take forever. So instead, we're going to use a formula. What's n in this one? Nope. Yeah, 100. We're finding the sum of the first 100. So we're taking the sum of 100 numbers. Which means 100 is your value for n. What's a sub 1? Yeah, the first even number, the even natural number, is 2. What's the last one? 200. Okay. And then divide everything by 2. And now, once again, you can very quickly find your answer on this one. What do you get, by the way? It's like 10,000 something, isn't it? Yep, 10,100. And that was a whole lot quicker than trying to take 2 plus 4 plus 6 plus 8 plus all the way up to 200. Okay? So like I said, number one idea, you're going to have a couple of problems on the worksheet I give you today that have application type things. But otherwise, main idea was, when do I use a formula versus not? Okay? Anybody have any questions? Otherwise, the rest of today, if you're still working on the worksheet from yesterday, you got plenty of time to do it. I'm going to give you another practice worksheet today. Before next week, then, we're going to start moving into geometric sequences and series and what that's all about. Okay? Let's go to work. I will hand out the new worksheet as you're working.